Hello guys, in today's episode I want to show you what is the infrared and how to use it in your projects. So what infrared really is? The infrared is a electromagnetic wave that oscillates in a frequency of roughly 10 terahertz, and it has wavelength of 1 millimeter. So how, you may ask, calculate the wavelength if we know frequency. So to calculate it, we need to know the speed of our wave, and then we can just divide it by frequency, or we can times it the time of the cycle, and we will have the wavelength. So you may ask how to transmit it, how to transmit IR, how to receive it IR. So to do it, it is pretty simple. You just need a transmitter diode and receiver diode. Receiver diode is sometimes called receiver phototransistor, but I will call it receiver diode because they're mainly in the same packages and they do the same thing. So we just need to connect the supply voltage to our transmitter. Of course, it is very, very delicate, so you don't want to feed the whole voltage into it. You need to step it down with a little resistor. And then we need to create AC. The easiest component to create AC from DC is transistor, so we need to just connect, depending on the input signal, we just connect and disconnect our little transmitter to ground, so the electricity flows through the LED and creates our infrared light. Then we need to receive it. We receive it with a pretty simple way. Of course, there should be some kind of resistor, and there should be some kind of resistor too. But to make the schematic a little bit easier, I just didn't write the resistors down in here. What we need to do in here is just mainly do the same thing. We just need to connect the power to the receiver LED, and the receiver LED connects our power to ground every time it receives more or less mainly infrared light. So when it connects to ground, it lets the electricity flow through here, so the more electricity flows through here and through the cap to remove the DC, and then we just can amplify this current that flows through this little resistor and then to the ground. And that's mainly everything that you should know. I can show you a little simple example of a little use. Here we got the multimeter, which is obviously set to the 2 volts AC setting. It measures just AC, low voltage AC. Here we have the multimeter. Here we have little receiver LED and remote control. And as you can see, when I press the button, the voltage increases, and when I release the button, it goes down again. So that's the easiest use to show you that the infrared is just received by the photodiode. Of course, the photodiode here, it works a bit more like a phototransistor, but it can generate its own signal too if you will connect it straight away to the amplifier, but it creates a bit higher amplitude signal in here, so it's easier to amplify it. But anyways, let's now show you some practical examples how to use it, and for example some waveforms and some other interesting stuff. And so let's go on and do it. Okay, so I have connected everything. The setup is a bit more complex than the last time, but I hope you will understand everything. And after explanation I will draw a little schematic so it will be easier to understand. So what I have done here. Here we have the power supply, LM317 power supply, set it to 9 volts, and I am feeding the output to the receiver and transmitter at the same time. Here I have the square wave generator, which outputs normal square wave with a 50% duty cycle, maximum amplitude, which is around 10 volts, and I am feeding it inside my transmitter. And then here we have the path that the infrared travels through the transmitter to the receiver, and then the output is connected to little filter board right in here. If you can, I hope you can see it. To the little board right in here, to which I am connecting my multimeter and my oscilloscope. So the output is so noisy that you will not see any kind of good waveform from that, so I have added this little filter in here. And this little amplifier that is on this board, it is a pre-amp stage. It doesn't amplify the signal enough, so you need to get rid of the noise and then amplify it again. So mainly on the oscilloscope screen I am displaying the voltage RMS, AC voltage that comes out of the receiver, and then after filtering, this is this voltage. And if I will cover up, as you can see, the path from the receiver to the transmitter, as you can see, the voltage drops very much. If I will remove it again, and there is a path for infrared, it goes. So this is the biggest minus of the infrared. You need to have clear path without any obstacles to transmit infrared. So I am fitting in normal square wave, and this is other minus. I am fitting in to this circuit normal square wave, but as you can see I have pretty strange waveform on the output. So this is the second biggest minus of the infrared, which is that it doesn't transmit the signal in 101. It doesn't transmit signal 1-to-1. It just disturbs it a little bit, deforms it, and as you can see, every time it is changing we have a high peak of the voltage, as you can see. Of course, if I will connect it before the filter, which I can of course show you, the noise is a bit higher. Here we have the output, which I will connect of course without the filter now, and the voltage from the multimeter disappears because I have disconnected the signal. As you can see, it's a bit more noisy and the peaks are even better. Of course I can tune a bit more the filter, but the waveform amplitude will be even smaller and my multimeter will not be able to measure it. So this is pretty much this circuit. Now I will draw a little schematic so you will understand it a bit more. And this is how it looks like after filtering. So this is pretty much about wraps it up. The setup is this time a bit more complex, but I think it is easy to understand, and now I will draw a little schematic. Of course I will show you the schematic of the transmitter and receiver, and then I will draw a little block diagram in which you will see how this whole thing is working. So here we have our infrared transmitter and receiver schematic. Here we have the transmitter schematic, and here we have the receiver schematic. So the transmitter works pretty simple. We just supply the 9 volts through 1 kilo ohm resistor to the transmitter LEDs, 2 in series, and then we just connect them with a transistor BC548, in this case, to ground. And it is of course changing the collector emitter path, current from the collector emitter path, based on the input current. So it draws current a little bit from your source, but not very much. So this was the transmitter. Here you got the receiver, which is powered from 9 volts too. So here we have the signal. Of course, here is a little mistake. I'm very sorry, but I have polarized in reverse the receiver. It should be polarized in this way, here, like that. So our receiver receives the signal, and it's changing the current that is flowing in here. So then the current splits in this junction and goes in here. Then we remove from the signal the DC. Then we have volume control potentiometer. Then it feeds into the amplifier. The inverting input of the amplifier is connected to ground, so it will amplify all the signal that comes in. Here we have little gain boost capacitor, and then we just remove the DC on the output with a simple capacitor, and then we connect our load. So let me now show you the block diagram of the measurements that I have done right in here. So now I have the block diagram of the circuit that I have built right in here. So I have my LM317 power supply that is set to 9 volts. I connect this power to the transmitter and receiver. To the transmitter, to the input of the transmitter, I have connected a little square wave generated by my generator. And then it goes through the air to the receiver. Then the receiver outputs the signal pre-amplified. Then it goes through a little RC low pass filter with a rheostat variable resistor in here. Then it goes here. Here we have the capacitor from the filter, and then the whole signal is connected to the scope. And this is mainly how our waveform looks like. So let's examine it a bit more. So now I'm in the hold mode, and this is how the waveform looks like. As you can see, it bumps up to the high voltage level, goes nearly stable in here, then it goes down, and as you can see, the capacitor like overcharges a bit, and then it goes to the normal level. So it's like a bit overshooted by the receiver LED. So as you can see, the receiver LED has some overshoot that you need to think about. Then of course, when switching to the high state, it overshoots a little bit too, and then goes a little bit stable, and then the same cycle repeats. Every changing is a bit overshooted by the receiver LED mainly. So that's like the whole functional thing of the whole circuit that you can measure by yourself. If you don't have oscilloscope, you can just measure it with a multimeter, as I have done it. You can just check the voltage input and input. Sorry about the mess that I have with cables right in here. So you can just measure this stuff with your meter. You can just measure if the transmitter works when you just cover up the sensors, and then it works. And the transmitter and receiver is, as I showed you, based on LM386. So you can connect mainly a 8 ohm load to it and connect your phone, for example, to the transmitter and transmit audio. I was trying to do this, but the quality is so low that there is just no reason for sending some signals like that through this transmitter and receiver. So it is just better to transmit a square wave like I have done. So that's pretty about much wraps it up for the transmitter / receiver circuit with infrared transmitters and receivers. So see you in the next episode, and if you want to see more projects, videos like that, visit my website www.ardugeek.pl. Thanks for watching.